Today in this lesson, I will explain the acidity of carboxylic acid. So normally the carboxylic acid are weak acid. The majority of their molecules are undissociated in water. So why? Why they are weak acid? The answer is very simple. For example, if I take an example of ethanoic acid, which is also known as acetic acid, when we dissolve this acid in water, only partially, not completely, acidic acid dissolved in water, it produces less number of hydrogen ion. For this, we have very low value of Ka. So, so that is the reason mostly they are weak. Okay, now here another question arises. Can the acidity of carboxylic acid change? The answer is simple yes. We can change the acidity. How can we change the acidity? The if electron withdrawing groups bonded to the carbon atom next to the main functional group make the acid stronger. Okay, now to explain this, let me show you a very important example. The first effect on the acidity is the substituent effect on the acidity, and that is basically on the alpha carbon atom. Okay, now let me show you example here. Now this is acetic acid, and this in this acetic acid, this green part is the main carboxylic acid group, and the carbon next to is called alpha carbon. Okay, so first I will discuss that if we change something in the alpha carbon, so acidity will increase or decrease. Okay, right now the value of this acid is given in pKa. For the pKa, we have to remember one point here. When we have a higher value of pKa, it means it is weak acid. But when we have a lower value of pKa, it means it is a stronger acid. Okay, so let's suppose if I change any one of the hydrogen. Now in this example, this is chloroacetic acid. In this chloroacetic acid, one hydrogen is being replaced by electron withdrawing group chlorine. So because of this chlorine, what happens? Now you can see the value of pKa just decrease. It means it become more acidic. Okay, if I just replace another hydrogen, so what will happen? Yes, the value of pK again it decrease, because now we have two electron withdrawing group. And if I replace the third one also, so you can see a very huge change in pK. Now the pK value is very low. If we have very low acid, it means this one is the stronger acid. Okay, now here the question arises, why this thing happening? The reason is very simple, because of inductive effect. These electron withdrawing group withdraw the electron toward their cell. So this part become more electronegative, and on the other hand, this part become more electropositive. Or you can see, or you can clearly say that this one become positive. So when it will become positive, so it will easily break down into a H plus sign. So that is the reason, because of the electron withdrawing group attached on the alpha carbon increase the acidity. So we can have this simple trend that the increasing electron withdrawing group on the alpha carbon, we have a increased acidity. Okay, now the second example, what will happen if I just change the position of the electron withdrawing group in the respective uh, carboxylic acid. Okay, let me show you this example. Now you can see this is the 2-chlorobutanoic acid. Right now, this one is alpha carbon, and the carbon next to alpha carbon is beta carbon, and the last carbon that is next to the beta carbon, it is gamma carbon. Okay, now what do you think if I just move this chlorine to beta carbon? So do you think it will increase the acidity? Okay, let me show you. Now you can see, previously it was 2-chlorobutanoic acid, now it becomes 3-chlorobutanoic acid. So because this change, the pKa value, yes, the pKa value increases. It means it become weaker acid. Okay. So with this trend, if I just change this value, replace this basically chlorine to this carbon, so what do you think what will happen? Yes, the answer is very simple. The value will also increases. Now, this is another effect when we just change the position of the electron withdrawing group to the carbons next to the main functional group. So we have this kind of trend that if we just move it away, so the pK value decreases, mean the acid become weaker. Okay, now let me give you some an example for aromatic acid. Okay, now here this one is benzoic acid, and benzoic acid has a pK value is 4.19. Okay, now I just ask you, what will happen if I just put electron withdrawing group to the ring? So yes, what will be the answer? Yes, answer is correct that the value will decrease. Now you can see right now, the nitro group is electron withdrawing group. So because of this electron withdrawing group, so the value decreases. Okay, now we have another thing here. This nitro group can be on the para position or the meta position. Now you can see, now when I change this nitro group on the para position, the value decreases more. But on the ortho position, we have the lowest value of pK. It means this one is the strongest acid. The reason is very simple, because the electron withdrawing group is very near to the which part, the basically the main carboxylic acid group. Okay, now I have a, in the last I have a simple question. What will happen if I just put electron donating group? Previously I was talking about electron withdrawing group. So if you just understood about the concept about electron withdrawing group, so what will happen if I just introduce electron donating group in the carboxylic acid? So yes, answer is very simple, that the pKa value will increase, though it will become less acidic. Okay, now you can see here OCH3, right now it is electron donating group because it donate electron in term of lone pair to the ring. So the value becomes higher. So higher value means higher value of pico means the acid become weaker. Thank you.